زدنا علما وارزقنا فهما. آمين. Right. So yesterday you did a contest. Let's see. Okay. So I think Ahmed didn't join the contest. So do you know why? Anybody knows? Okay, good. Right. No problem. So you did the contest yesterday on 26, and it was JOI 22. And then most of you got 210. Christian, Mutahir, and Hasan Arif. And then Hayan and Gamas. Okay. Okay, then I think you haven't solved problem C. So should we discuss it? Okay. Let me read the problem. Okay, wait. I think there is another problem, a better problem to discuss. Which one? Maybe let's discuss this one. Okay, you can read the problem. And then once you finish reading, you can try the first subtask. This is the easiest. Okay, once you finish reading this problem, you can try the first and the second one. Okay, there is an idea from Mutahir. Okay, could you wait? Should we use PFS? I think there is no graph here. Okay. Which subtask do you mean? Wait, actually, we are discussing this problem, Singaporean NOI or NOI 20 and 25. Okay, yes, it is just a number line, not a graph. So it will be easier. Okay, any other idea? So if k is equal to 1, then it means there is only one mines. And there are some monsters. So how to defeat all monsters? Okay. Yes, that's right. So we will check, we will compare between what? Between the road and the distance. Okay. Which one is greater? What if they are same? What if the distance is equal to the height? Which one we will choose? So what if, so there is a case where hi equal to absolute this, or okay, can you explain what should we do if h is greater than absolute, or what if h is less than absolute, and what if h is equal to absolute? Yes, that's correct. We will prefer this because we need one additional cost for detonating a mine, right? So we will always choose h if they are equal. Otherwise, choose the smallest one. Okay. And then if there is at least one monster, we need to activate the mine, so we will increase the answer by one, right? Okay. Yes. Yes. So there are two cases. If there is a monster that the absolute is cheaper, then we will increase the answer by one. Otherwise, just do nothing because we always use this. Okay. Okay. So from this idea, actually, you can improve it to some several subtasks. Okay. So I will give you 10 minutes to complete your idea. Okay. And write down your idea. You can write down the idea subtask per subtask, and you can also write down the idea for the full solution. Okay. I will give you 10 minutes. You can also implement this if you know the solution because it is easy. Okay. Okay. Okay, there are some ideas here. And okay, let me read musician's idea.
Dari mana? Emang dari mana kamu?
Yes, the idea is correct. So if you try to implement it, okay. Okay, actually your idea is correct. Don't worry. Because the first observation is like this. You know, if hi is less than absolute, I mean the distance to the closest line, we can easily find the closest line using two pointers or sliding windows. Okay, if hi is less than the distance, so it is always better to use hi. Even though the difference is only 1. So for example, hi is equal to distance minus 1. But still, wait, less than. So I think it's plus 1. Still, it's 1 is always better. Why? Because, okay, if we want to decrease by health, wait, I think this like this. Okay. Or, okay, yes. If you want to decrease by health, then the cost is like this. But if we want to defeat them using mine, there are two cases. It can be hi without plus 1, or sometimes it is hi plus 1. So this one is always better. Okay, wait. Okay, yes, I think like this. Okay, maybe let's just use an example. For example, this is 7 and the distance is 8. Of course, using this one is better because sometimes we need to increase by 1. Okay. And also if hi is greater than this and distance, then the best way is using the distance. Even though the difference is only 1. For example, like this. You know, for this either 7 or 8. But actually if we make it 8, then we already activate a mine. So it will reduce the cost for the other monsters, right? Okay, so this one is better than this one. Okay, so that's why this one is always better. Okay. Then what if they are same? So we will favor HI because if they are same, sometimes it is like this. And this is never better than this. Okay. What else? Okay, then if we use HI, okay, then it will not affect the others. But if we use this, it may reduce the cost for the others, right? So we have to check which mine is the closest one. For example, if this mine is closer, then we will activate this instead of this. Okay. Even though the difference is only one, but this one is always better. Okay. And then what if there are two closest mine? I mean, the distance to the mine are same. Then what should we do? If the distance to the mine are same, it means this mine are adjacent, right? They are adjacent mine. Okay. So yes, there are some adjacent mines such that there is a monster in the middle. Okay. So at that case, if this mine is already activated, so we will use this because it is cheaper. No need to add additional cost. Okay. Otherwise, if it is not activated yet, we will prefer this. Why? Because it can reduce the cost for the next monster, right? Okay. So the idea is like that. So if we prefer this, then we have to check which one is closer. If left is closer than right, then we will choose left. If left is farther than right, we will choose right. What if they are same? If they are same, we will check if left is activated, then we will choose left. Otherwise, we will choose right. Okay. So like for this problem is just greedy and maybe 2 pointers and sorting. I think we need to sort since it is not sorted, right? Is it understood? Okay. Okay, so
Guling.
let me check why this code is got wrong answer. Okay, so you try to solve sub plus 2. Okay, equal to 2. Okay, congratulations. Decision got accepted just a few minutes ago. Okay, let's see. Okay, I think else we have to check, or maybe we can change this line, become P or K. Okay, P or K. If either P or K is activated, then we will turn this on. I think wait. For this case, we can make another variable, for example, variable M for middle. So, if M is true and P is false and K is false, then answer plus plus. Okay, do you know why? Because, okay, at first, there is only one monster satisfying this, right? Because the positions are different. There are no two monsters in the same position, right? So this case is only one, at most one monster in the middle of two mines. Okay. But at that time we cannot decide yet. Okay. Whether using the left one or the right one. Why? Because for example, this monster is the first monster. We haven't checked the next monsters. So we cannot decide because sometimes the next monster is or came to this mine, sometimes came to this mine. So we don't know. We don't know. So just store M equal to 1 like this. But if either P or K is on, then we can easily skip it. Or actually we can check it later. just remove this and make it M, okay? But in the end, if PRK is on, then okay, M is false. After that, the answer is equal to answer plus P plus K plus M. Okay. Right. Any questions? If there is no, then we can continue to the next one. Wait. I think we have discussed this. Okay. Okay, I think different. Okay, let's discuss problem B. The first subtask is easy. Okay, let me ask Mutahir how to solve the first subtask. Okay, yes, just brute force, right? Just do a simulation to move the rabbits. Okay. And then let me ask Hayan how to solve the second one. And Nishan got the idea for the first three subtasks, and I think they are correct. I mean the idea are correct. Okay, good. So for the first subtask, we can do a simulation to move the rabbits. And then for the second one, yes, we just need to care about the exposition. And the order of their position will never change. If there are two rabbits, one of them is to the left, one and the other is to the right, then they will never swap. They will never swap. Why? Because if there is a thumb here, of course, they will move together over there. If there is a thumb here, then they will move to the left together. If there is a thumb here or around here, then they will move. I mean, the distance will increase, so they will never meet and change their position. Okay. So we can easily check like this. For each rabbits, we just need to know how many thumbs here and how many thumbs here. For example, there are 5 thumbs here and 1 thumbs here, so it means it will move over there 5 times and go back once. So it means just increase it by 4 times 2, right? Why times 2? Because, okay, because like this, 2 columns, right? we will move 2 columns. Okay, so that's the solution for subtask 2. And then what about subtask 3? Okay. Jishan already got the idea. The main observation is the order of thumbs doesn't matter. Okay. The order of thumbs doesn't matter. Okay. So that's why we can easily do the thumbs in any order. So we can easily start from the first rabbit to many thumbs at once, and then second rabbit to many times at once, and yes, and so on. So we just need n thumbs, so the complexity become n squared. Okay. Do you know why? How to prove that the order of the thumbs is doesn't matter? So anyone can prove? Maybe Zishan, can you? We want to prove one statement. The statement is the order doesn't matter. Okay, yes. It is okay if you cannot prove, just use your intuition and just do this. If you got the intuition, try to prove it by submission. Okay. Just implement it to solve the third subtask and then submit it. If you got 32 points, okay, it means that observation is correct. Just move on to the next subtask. Okay, no need to prove them. So we can utilize the subtask to prove our observation actually. Okay. Okay, and then do you curious with the proof? Okay, the proof is just like this. We have to prove that their position never changes. If one of them is to the up and one of them is down, then they will never change their relative position. Okay. And also when they are in the same diagonal, they will always in the same diagonal. Okay. Okay. Let's prove when they are in the same diagonal. The proof is same between the right down diagonal and right up diagonal. So just prove one of them. Okay. You know, if there is a thumb and the thumb is around here, so it will move to the left. And of course, it is also inside this area, right? So it will also move to the left. Okay. Okay, so it is clear for this area. And how about this? It will move up, and of course it will also move up, right? Okay. And then if the thumb is around here, it will move to the right, and it is also moved to the right. Okay. And also for this, it will move down. Otherwise, okay. And this one is also moved down, right? Okay. And then for this position, all of them will move over there. So they are still in the same diagonal, right? Okay. And vice versa here. And also in the middle, if the thumb is around here, they will move go away each other, and they are still in the same diagonal. And then what if it is around here? Then it means it will move to the right and it will move up. And okay, surprisingly, I think not surprising, it will still in the same diagonal. Okay. And also around here, this one will go here and this one will go here, and they are still in the same diagonal. Okay. So it is proven, right? So anywhere, and when there is a thumb anywhere, they will always in the same diagonal. Next, we have to prove what if they are up and down. Okay. They are up and down. So there is a diagonal and they are in different zone or different area. Okay. They will always maintain their position. Okay. For example, if there is a thumb here, this one is go up, this one is go up. Okay, still the same, right? And also for this, both of them will go down. Or let's divide into some sections. Okay, this one is correct, this one is correct. What about this? Of course, this one go down, this one go up. Okay, they will move away each other. And for this, it will go here and it will go here. The diagonal will move to the same direction, so their position will still remain same. What else? If it is around here, it will move here and it will move here. Okay, they will move farther. I mean, they will move away each other. So yes, their position are same. And of course, these are correct as well because it is symmetric. And also for this, both of them move to the left, and for this, both of them move to the right, and also the middle. And also around here. Yes, their diagonal move with the same length, and of course here, here. Okay. Then with the same way we can easily prove its position. Okay. So the conclusion is yes, the order of the operation doesn't matter. So we can solve the third subtask. Okay, then let's move to the fourth one. Any idea? After we know that observation. Okay. think the idea are same between the fourth subtask and five subtasks. Maybe it is just about the different constant and different complexity. Okay. Okay, just think about the full solution. Can you guess which data structure we will use? Okay. So the idea is like this. Just combine these two subtasks. The second subtask, we just calculate the number of thumbs in each direction. And for this, we know that order doesn't matter. Okay, then just combine them. So we just need to check how many, uh, I mean, how many thumbs here, 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 and here. Okay. If you know the number of thumbs in a direction, then we can easily know the final position, right? Okay. Is it understood? Okay. And then do you know how to know the position of each direction? At first, we have to rotate this how many degrees? Can you predict how many degrees we have to rotate? Yes, that's correct. 45 degrees. So it became like this. Okay, then it look like easier, right? Looks like easier. And then if there are some sums here, it will go up. There are some sums here, it will go on the right, and so on. Okay. What else? I think if it is like this, it is easier to prove that order doesn't matter. Okay. Because we can think about its axis. So x-axis and y-axis. And based on the observation in the second subtask, we know that the position of x-axis doesn't change, and then we know that the position of y-axis doesn't change. Okay, so yes, it means it is also applicable in two-dimensional. Okay. Do you know how to rotate 45 degrees? How to rotate them? Any idea how to rotate them? Usually it is using transformation. The constraint quite large. is around 5a5 plus 5. What else? I think we need a pair. Okay, once again, do you know how to rotate them? In order to rotate them, we can do this. If the input is x and y, then let's change it into x plus y and x minus 1. Okay. So AI is equal to a pair of x plus 1 and x minus 1. Okay. Is it understood? Is it correct? So, x plus 1 is just like this. It is just like we have another axis. The first axis is here. Okay, this is x, this is y. X plus y is here. Sorry. I think like this. So, if we, sorry, if the x plus y is 0, then they will around here. If they are 1, around here. If equal to 2, around here, and so on. And also x minus 1 is this axis. If x minus 1 is 0, it is around here, and so on. Okay, you got it? Are you with me? Okay, good. After that, it will be easier if we know it. We can easily know how many position here, 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 and here. How to do that? We can sort them. Sorry. I think it should be like this. Okay. Okay, then what should we do? Wait, I think we have to store the index as well, because the output would be in the same order with the input. Okay, then into this. Wait. Okay, let's make it triple I. Okay. Okay, it will be like this. And then at first we can easily, for checking left and right, it is like this. We need a map to count the number of thumbs. Okay, I think we have to input the number of thumbs. Really, we just need to know the intensity, right? What should we do? Okay, just need to do this. And then how to calculate the number of moves to the right, for example. So at first, if there is a thumb at X, maybe we can do this. Wait. And do this. We need a map for left, right. When dot second are same and when first are same. Okay. Then first of all, first x plus by 2, right? And then yx like this. Okay. What else? For example, j is equal to ai dot second, means it is the index. I mean the index of the repeats. And then we need to know the value of this right. Wait. I mean right first xx. Okay, yes, I think so. After that, right plus by 2. Do you know why? So right means the number of value to the right. If there are 5, so it means we have to move to the left 10 times, right? Okay. What does it means? Okay, wait. Yes, we have to move to the left 10 times. But after that, when we move here, okay, then it means we will go 8 times. Okay. Yes, actually it will be go to the diagonal, but we already rotate this. And after that, we want to rotate again. So after we move them, in the end, we will rotate again. Okay. Is it understood? How to rotate them? We need to do this. We already know, sorry. I see, I think we have to change this. Xi become x plus y. And then y become x minus y. How to do that? Maybe we can do this. yi minus y. Yi is equal to xi minus 2 times yi. Do you agree with this? It means we rotate them. This become x plus y and this one become x minus y. Why? This is x plus y minus 2y. Okay. So it become x minus y. And then in the end, if we want to know the real x, we have to add xi, yi and divide by 2. Do you know why? X means x plus y means x minus y. And the sum of them are 2x and divide by 2, it is equal to x. Okay, then what else? The y coordinate is xi minus yi divided by 2. Okay, how do you think? Okay, yes. So let's go back here. Okay, let's think about this position. If initially there are 5, so we'll go to the left 10 steps. After that, actually it become 8 only. After that, when we go here, it become only 4, right? This is minus 8. Wait. Or we can simply do this, I think. Okay, we have to notice that for this rabbit, it may have many thumbs, right? Actually, TJ thumbs. So if initially the previous position is move right times, so it will decrease by 2 times TJ. Is it correct? It will decrease by 2 times TJ. Yes. For that, actually plus, because it is previously minus. And then it will move again 2 times TJ. Okay. Yes, so let's do this. 2 times TJ. And then it is X or Y? X, I think. XJ. Wait. I think it should be second. Okay, yes. And then XJ plus by right. And then again right plus by 2 times TJ again. Okay. Or we can make it like this, I think. So no need to multiply it by 2. Okay, because every movement move by 2, right? Here move by 2. By 2. Here is also 2. And so on. Okay, what else? Then for going up is equal to first xj, right? And then up plus by again tj, and then yj plus by up, and then up plus by tj. Is it understood? We already checked this direction. After that, how to calculate the number of this? Can you guess which data structure we need? We need a Fenwick tree. Okay. We need a Fenwick tree to calculate the number of thumbs. Okay. But before that, I think we need to compress them. Because the row and the column is like this. So how to compress them? I think
Minta gigitan.
okay, I think we need to do this. We have to compress the Y position.
Bedanya ini MBG gimana? Dalamnya MBG enggak?
So maybe we can just simply iterate over all of this. Yes, I think.
Iya, 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 jatuh.
Or we
Dalamnya
can
jatuh.
also
Ambillah.
sort based on Y for sorting by X.
Coba tinggal diambil lagi.
So let's sort by Y. Okay, or we can also do this, I think. We can compress both of them. How to compress them? We can just do this.
Biar, biar. Semut, 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 semut.
Okay, we can simply do this and also do this for the second. So we can change the value of AI. AI is equal to first of xi and second of yi. Okay, it is like this. Any question about this? We can compress them. So we don't need a map after compression because we can just make an array instead of a map. For example, we can make like this: up, down, left, and right. What else? We can also make a prefix sum for ref x and ref y.
kok tidak kok.
So we will do this for every sums. We will assume it as moving down and left. Okay, then down ax dot, wait, this is first and this is second. This is up, down, this left, this right. Okay. So it means for the first coordinates, we will move it down. And then for the second, we also move to the left. And then we can do this. What? Down AI dot. I think this dot first, not only dot first. Okay, like this. Dot first minus by 2. And then in the end, sorry, up AI dot first increase, sorry, yes, increase by 2. So here the y position will increase by this, I think, up minus down. Okay. And then the x position increase by right minus left. Okay. Any question up to this point? Okay. So this is how to move or direction. And then we will do this also for this and this, I think. We can easily calculate the number of sums before it and the number of times after it. We can make two variables before and after. Initially, all of them are after. And then after reduced by I think not reduced by 2, but reduced by dj. And then before increased by dj. And you know, every position here will increase by before and reduce by after. What do you think? Actually, after is here, before is here. But we have to subtract with this, right? It is before, but except this, except up, I think. So let's reduce by up. And then for this, it is after, but reduced by down. Minus after. Or maybe we can do this to make it easier to read. And this is after reduced by down. Okay. What do you think? Then how about this? Wait. I think we can simply use prefix sum, right? Yes, I think just simply use a prefix sum only and victory.
Bersembunyi kah?
We can do the prefix sum like this
Iya, sayang.
for the second position.
Sembunyi. Mana yang sedang
Plus by 2.
bersembunyi? Dah.
And then just do the prefix sum like this.
Yeah.
Okay. So here we just need to check the prefix sum. This is increased by prefix wait. If so, then actually we don't need up, down, and left, right. Because we can simply use prefix sum and we can easily know this, the movement of this. And we can easily know the movement of this and this and this. I see. Then no need to sort them actually.
Pokoknya di ini.
Okay, do you know what I mean?
Pokoknya di
So maybe we just need n log n for compression. And the other just on. Just use prefix sum. I mean prefix sum for x and prefix sum for y. And for each rabbit, we can easily count the number of thumbs here. So we know how many movement that increase the value of y. And then how many thumbs here reaches the value of y, and how many thumbs here reaches the value of x, and how many times here it goes to the right. Okay. Okay. Yes, so it will be easy. Okay. Any question about it? If there is no, I think that's all for today. Thank you very much for with the question. And see you again next week, inshallah. And let's close our meeting with Rahim. Sebelum aku langsung mau pindah ke